Okay, we're on chapter 2 now, and we're going to start with section 1, problem 15. So the next couple of problems are these using the limit definition for the derivative to come up with the answers. So in this particular case, we have the linear equation 3 plus 2/3 s. So the limit definition for the derivative is the limit as delta x goes to 0 of f of x plus delta x minus f of x divided by delta x. So in this case, we could just say h. H is the function and s is the variable. So we could say that h of s plus delta s, what we do is we take the original function, which is 3 plus 2/3. Instead of putting in s, we put in s plus delta s. And we already have h of s up here. So then we plug it in here. We'll plug it into the limit definition. So we have 3 plus 2/3 quantity s plus delta s minus f of s, which is the quantity. So we put a negative sign, and then we put in parentheses just to show that we have to do that to both the first and second parts of it. And then we divide that whole thing by delta x. And if you let delta s go to 0, this would go to 0, this would go to 0, and you'd end up with an indeterminate result. So what we do is we don't really use the factoring out technique because they're canceling it. Well, we do kind of use the canceling out technique because we're going to end up canceling out delta s here. Let me make sure I use delta s instead of delta x. Okay, well, 3 minus 3. So those two are going to cancel out and go to 0. I should put delta s here, not delta x. It's always hard when they change variables. So anyway, the limit is delta s goes to 0. So I'm just going to mark through these. That cancels out with that. This part cancels out with that. And all we're left is 2/3. Okay, I have to be careful here. So we're not canceling out 2/3. We're just canceling out the 2/3 times s. So we still have this additional 2/3 times delta s. So we'll have 2/3. This 2/3 times the second part, 2 times delta s. And then we divide by delta s. And then the delta s's cancel out. And so you end up with the limit as delta s approaches 0 of 2/3, which is just 2/3. Okay, because delta s isn't even involved in this. So the limit of a number is the number. So the answer is 2/3. This is problem number 17. So we have a little more complicated expression. Here we have a square, so have to be careful. So before we write the limit definition, let's just go ahead and do what f of x plus delta x is, because we're going to need that. So we have 2. For x, we put in x plus delta x, and we square that. And then we have x plus delta x, and then we have minus 1. So every place there's an x, we put in x plus delta x. And I'm actually going to multiply that out. So we use FOIL on that first bit. So we'll have x squared plus 2x delta x plus delta x. And I'm putting parentheses just to make sure you know that I'm squaring delta x. I'm not just having delta x squared. It's delta x quantity squared. And then we have plus x plus delta x minus 1. And if we multiply out the whole thing by 2, we get 2x squared plus 4x delta x plus 2 delta x quantity squared plus x plus delta x minus 1. And so I'm going to leave it as that. And so when I use the limit definition, limit as delta x goes to 0 of f of x plus delta x minus f of x divided by delta x, and I plug in everything. I'm just going to copy this thing down. So clone that, bring that down. So that's f of x plus delta x. And I'm going to add another page just to, because I'm running out of space here. So that part is f of x plus delta x. And then we subtract f of x, which is 2x squared plus x minus 1. And this whole thing is divided by delta x, and we take the limit as delta x goes to 0. Okay, so now we should be able to cancel some stuff out. So this cancels out with that. This cancels out with that. This cancels out with that. So what we're left with is the limit as delta x goes to 0 of 4x delta x plus 2 delta x quantity squared plus delta x. So it's this one, and that one. Everything else cancels out. All divided by delta x. And then after we simplify the numerator, then we can cancel out delta x's. So you'll see that, so this cancels out with that, and we do it with each element. So we don't just do it once, we have to do it every time on every element. So those cancel out, and then there we get rid of one of them. So we end up with 4x plus 2 delta x just to the first power plus 1. So delta x divided by delta x is 1. 4x delta x divided by delta x is 4x. And this divided by that. Okay, now when delta x goes to 0, this goes to 0. So we take the limit. This goes to 0. These are not affected because this doesn't have any delta x and this doesn't have any delta x. So the final answer is 4x plus 1, which is the correct answer. Problem 21. Okay, so this is a reciprocal type function. So the tricky part about this one when using the limit definition is definitely not just sticking in delta x, because that's the easy part. So what we'd end up with is 1 over x plus delta x. So for x, we put in x plus delta x, then we subtract 1. So we stick it into the limit definition. The limit as delta x goes to 0 of 1 over x plus delta x minus 1 over x minus 1, all divided by delta x. So here we have f of x plus delta x minus f of x divided by delta x. So that's the limit definition. So when you have reciprocal functions or rational type functions, you have to just find a common denominator and simplify it. So that's the first thing we do. We want to find a common denominator here, and then we want to make it into one fraction, and then we might be able to simplify something. So when you have two fractions like this, all you have to do is cross multiply basically. So we get 1 times x minus 1. So we have 1 times x minus 1 from here times there. Then we add a negative sign. So then it's negative 1 times that. And the common denominator is the product of those two. And then we all divide by the whole thing by delta x. Now we can simplify here because we're going to be able to cancel stuff out. So this cancels out with that. This cancels out with that. And all we're left with is negative. So we're left with negative delta x. We divide by this product. Like that. Okay, now how do we simplify this? Well, we make that into a fraction. So we have a fraction divided by a fraction. And then you take the reciprocal. So the reciprocal of delta x over 1 is 1 over delta x. So we'll end up with delta x divided by x minus 1 times x plus delta x minus 1 times delta x. So this delta x here just becomes numerator. So I've gone from this 4-layer fraction to 2-layer fraction. Okay, so now what I can do is delta x divided by delta x is 1. And then I take the limit as delta x goes to 0. So what I end up with is negative 1 at the top. And the bottom I have x minus 1. And when delta x goes to 0, then the second term just becomes x minus 1. So the answer is negative 1 over x minus 1 quantity squared. Okay, we have 23, which is one that involves a square root. So we're probably going to have to use the rationalization technique. So again, we start out by just writing out f of x plus delta x. So for x, we put in x plus delta x, and then we add 1 to it. So the limit definition for the derivative is equal to f of x plus delta x minus f of x, all divided by delta x. So because we have square root functions, we can use the rationalization thing. So what we're going to do is we're going to multiply this, and let's do all the math first, and then we'll apply the limit stuff to it. So x plus delta x plus 1 minus the square root of x plus 1. So that's the original numerator. So then all you do is you just add the second term. And then you divide it by delta x times that second term again. Okay, so that's that. Now, we use FOIL on the top, so when you multiply these two together, you'll get just the quantity in the square root place. So this times that is that. And then the FOIL, the inner and outer drop out, and so the second term is just x plus 1. And then it's all divided by delta x times the quantity, the square root of x plus delta x plus 1 plus the square root of x plus 1. Make sure I've got this all right. Yeah, okay, we're good. And let's go ahead and put the limit back in here now. So, simplify, cancels out with that, this cancels out with that, so all that we're left with is delta x. So we have delta x, we can cancel out that with that, and that will leave 1 in the numerator. Okay, so when we take the limit as delta x goes to 0, this goes to 0, so we have the square root of x plus 1, so we just write it out. So we have the numerator is 1, and then you have the square root of x plus delta x plus the square root of x plus, pardon me, not x plus delta x, it's x plus 1. and then the second term is the same. So now you add those two together. So what you'll get is 1 over 2 times the square root of x plus 1, or 1/2 times 1 over the square root of x plus 1 to 1. That's your answer. Okay, we've got problem 25. And it asks to find the equation of the tangent line at a particular point, which is point 2, 5. So the procedure that you use is you use the limit definition to find the derivative, and then you so that'll give you the derivative, which is the slope of the tangent line. So you'll take that equation, plug in x equals 2, and you get a derivative number, which is the slope. And then you have a slope, and you have the point, so you can use the point slope of linear equation to find the actual equation of the tangent line. And I don't think we need to use a derivative. We'll just skip part C. Okay, so we're just continuing on like we did before. F of x plus delta x is equal to x plus delta x, quantity squared, plus 1. So the slope, the derivative, is the limit of as delta x goes to 0 of x plus delta x squared plus 1. So that's f of x plus delta x minus x squared plus 1, all divided by delta x. So we multiply everything out. So you'll use FOIL, so you get x squared plus 2x delta x plus delta x squared. So that's what we get from FOIL. We get 3 terms. Add 1. And then we have minus the quantity x squared plus 1, all divided by delta x. So we're left with these 2 terms, and then we can cancel out the delta x. So the final limit that we actually apply is this one. So you get 2x plus delta x. And then when you take the limit as delta x goes to 0, this goes to 0, and that just is 2x, so the answer is 2x. So we can use, I forget if we introduced the terminology. Yeah, I think we did. So we can say f prime of x is equal to 2x. So f of x was this, f prime of x is 2x. So at x equals 2, from this equation, you should put x equals 2, and you'll get 4 plus 1, which is 5. So we have the point 2, 5. But the derivative is a function of x. So all I have to do is stick x in to this equation. So that gives us 4. So the slope of the line is 4. And the point is 2, 5. So now we go to the point slope form of the linear equation. Which is this. This is the slope. These are the points. So this is 5 and this is 2. So you have y minus y1 is equal to m, which is 4, times x minus x1, which is this. So let's write that above that, x1, y1. So x1 is 2. And if we wanted to plot this, we would move this to the other side, so it would become positive 4, but we'd multiply out, so you'd have 8x minus 8 from, not 8x, 4x. 4x minus 8, and then you would add 5. So this is called the slope-intercept form. So the slope-intercept form says y equals 4x minus 3. So this is the equation of the tangent line. Y equals this. That says use a graphing utility to graph the function. So the function is x squared plus 1. The other line is y equals 4x minus 3. What we should see is that, so when we go to plot this, I have to minimize these things, get my graphing program going. Okay, so I'm going to plot those two lines, x squared plus 1, and the other one was 4x minus 3, I think. 4x minus 3. And so here we see that x equals 2, so let's move up a little bit. So at x equals 2, y equals 5. See the blue line, which is the tangent line, is tangent to the red curve, which is f of x. This is y equals f of x equals x squared plus 1. This is 4x minus 3, has a y-intercept of -3. And it's a slope of 4. You see, no matter how far we zoom in at x equals 2, the blue curve is tangent to the red curve. Okay, we're up to problem 34. So our function is f of x is equal to x cubed plus 2. So we had to find the equation for the derivative, and just like before, we can find the equation line is tangent to the graph f and parallel to the given line. Okay, so actually what we're going to do is, we don't know what the value of x is. What we're going to do is we're going to find the derivative, see what the slope of the other line is. So the other line, let's write this down, is 3x minus y minus 4 is equal to 0. So if we solve for y, we get y is equal to 3x plus 4. How to do that? Actually, that's wrong. 3x minus 4, I guess. Okay, what did I do here? 3x minus 4. So I could take y to the other side and make it positive, and then have 3x minus 4. That'd be the easiest thing, then switch the sides. Or I can add 4 to both sides, subtract 3x on both sides, and I have negative y is equal to negative 3y plus 4, and then I divide everything by -1, and I get that. So this is, so the slope of this line is equal to 3, and so we want the slope of the tangent line to this curve to also be 3. So what we'll do is we'll set the derivative equal to 3, solve for x, and then see what it is. So we're going to, again, use the limit definition at this point. And so we write it down here, f of x plus delta x. So you get x plus delta x cubed plus 2. And I'm just going to go ahead and multiply it all out right now. So this is a cubic, and you can multiply it out. You could do two ways. One way would be to do it this way. You'd do FOIL once, and you get x plus x squared plus 2x delta x plus delta x squared. So that would be that done twice, and then you multiply by x plus delta x. And you do that again, except you do this times that, this times that, this times that, and then this times that, this times that, this times that. So it's kind of, there's more terms, so it's longer than just a FOIL problem. It turns out that the answer is x cubed plus 3 x squared delta x plus 3 x delta x squared plus delta x cubed. And if this were to the 4th power, then it would be something like x to the 4th plus, I guess like 4 x cubed delta x plus 6. Anyway, there's a pattern. Actually, I'm going to tell you what the pattern is. I don't think you guys have ever seen heard of the Fibonacci sequence. Or I think that's what it is. No, that's not what I'm talking about. So it's called Pascal's triangle. So you make a triangle, and you've got 1, 1, and then you add these two together, and you get 2. So this plus that is 2, and then the outside continues to be 1s. So the next layer, you've got 1s on the outside. 1 plus 2 is 3. 2 plus 1 is 3. So this is x plus 1 squared is equal to x squared plus 2x plus 1. 1, 2, 1. And then when you have 3 of them, you get 1, 3, 3, 1. And if you did it the next level, you'd have 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4, and then you have a 1 on the outside. So this is for cubed, this is for squared cubed, so if you had x plus 1 to the 4th power, then the answer would be x to the 4th plus 4x cubed plus 6x squared plus 4x plus 1. And keep doing that. Anyway, the answer here. So let me just erase that. Just extra free stuff for you. So now we plug this. This is f of x plus delta x. So put that on the top. So you have x cubed plus 3x squared delta x plus 3x delta x squared plus delta x cubed. So that's f of x plus delta x, and we subtract off f of x, which is x cubed plus 2, divide the whole thing by delta x. Take the limit as delta x goes to 0. So that cancels that. Oh, I forgot one term here. Plus 2. Plus 2. I forgot that number right there. Okay, so I'll have a plus 2 right here as well. Okay, so that cancels out with that. So what we have left is 3x squared delta x plus 3x delta x squared plus delta x cubed, all divided by delta x. Okay, now we do the canceling out. And when you cancel that out, the delta x with each term in the numerator, you get 3x squared plus 3x delta x, so I lose one of those, plus delta x squared, and the denominator's gone now because I've canceled it out. Now you let the limit as delta x goes to 0, so that goes to 0, that goes to 0. The only term that's left is this 3x squared. So we can say that f prime of x, the derivative, is 3x squared. Okay, so that's our equation for the slope, and where the question we have is what value of x do we have when f prime is equal to the slope of this line, which was 3. So all we have to do is just set the two sides equal to each other. 3 is equal to 3x squared. So x squared is equal to 1. So x is equal to plus or minus 1. So there are actually two places where the slope is 3. And is that true? I think it is. So it says, find an equation for the line that is tangent to the graph and parallel to the given line. Okay, so let's plot the original function and the line that we're looking at, and see if that line is parallel to. So I'll show you what we're going to do here. So the curve we have is, the original curve was x cubed plus 2. The curve we're trying to be parallel to is equal to y equals 3x minus 4, so we actually don't need to put the y, we just put 3x minus 4. Okay, so we graph that. And I need to go to the standard zoom. So if you look at this line, it looks like it's going to have about the same slope as this line at x equals 1 and at x equals -1. So this slope of the tangent line here would be something like that, which should have the same slope as that line, and then also right there. Okay, so this is problems 37 through 40. So it's just looking at these graphs and trying to match up the ones over here. So the slope of the line is the derivative. So this has a slope. It's positive. Looks like about a slope of 1 because you go over 1, up 1, over 1, up 1. So what we should do is go over here and find out which one of these is a horizontal line with a value of 1, which is this one. So the derivative of this one is b. Okay, here we have a parabola. So we have a negative slope, goes to a 0 slope, and then becomes a positive slope. So the only one we have that looks like that, this is negative, goes to 0, becomes positive. It's all it's a continuous curve, so we don't have any jumps. So this one would be D. 39. So as there's no slope less than 0, so because the function is actually, I think, is a square root function. So square root of 1 is 1, square root of 4 is 2, etc. So anyway, this is so what you have is, I think this goes to infinity. Slope, it's hard to tell whether it goes to infinity. The slope goes to positive infinity, and then as you get larger x, the slope gets less. So that one would look like this curve. So that one would be a, by process of elimination, the last one has to be this one. But you can see for less than x equal less than 0, it's a -1 slope, and from x greater than 1, it is a positive slope, and at x equals 0, it's undefined because you can't draw, you can draw an infinite number of tangent lines. So it would be this one. So that one, of course, would be C. Okay, problem 43. Sketch the graph of f prime. Explain how you found your answer. So 43, the slope is the derivative, f prime is the slope of this line. And it's got a positive slope. And if we go over 4, we go up 4. 4 divided by 4 is 1. So this is just going to be a horizontal line at y equals 1. So f prime of x looks like that. Okay, 44 has a 0 slope. So this is a 0 line, horizontal line at x equals 0. So it would be like that. So this would be y equals 0, which would be equal to f prime of x. Okay, 45. We looked at that earlier. So you have a negative slope, then you go through 0 and a positive slope. The change would occur at x equals 4. So it's not quite like the previous problem. So if you have x equals 4 here, then it's going to look like probably something like this. Now, is it linear? I mean, all we know is that less than x equals 4, that it's a negative slope. It's a 0 slope at 4, and then it's positive. It could be. I mean, you could have x to the 4th power. That would actually probably look more steep, but you really can't tell for sure unless you go over here and kind of look at the numbers. If you go over 1, up 1, and you go over 2, and up 4, over 3, and up 9, then you could say it is a quadratic equation for one thing. So it's probably going to have a slope just like that. And 46, well, we just did this a minute ago. The only difference is that you have a slope of -1 up till x equals 4, and then you jump up slope +1. So this is +1. This is 1, then the slope is undefined at x equals 4. It says, sketch a graph of a function whose derivative is always negative. So 47. Well, the easiest one to do is something like a cubic, but it looks like this. So this would be, if you did y equals negative x cubed, and you plotted it, it would look like that. And so it's always negative. And 48 is the opposite of that. If you just did y equals x cubed instead of negative x cubed, you'd get something like that. Another example we'll see later is the function. It's kind of early to do this, but y equals e to the x. That function looks something like that. Or you could do y equals the natural log of x, which would look something like that. Both of those have positive slopes for their entire domain.